Greeting, my name is Mohammed Wardi. I am a final year student from UTM under the supervision of Dr. Dayang. For my final year project, I am working on a research entitled Object Detection Algorithms for Autonomous Navigation Wheelchair in Hospital Environment. For my introduction, I wanted to highlight how much object detection is a fundamental tool for automated navigation systems. Nowadays, we're familiar with autonomous navigation vehicles driven by sensors such as LiDAR and a combination with machine learning. But the question arises, would it be possible to have an indoor navigation system specifically designed to only function using object detection algorithms? And we wanted to add an extra layer to our investigation. We decided to study the context of hospital environments. It is important to have a safe, reliable transport system that can navigate the hospital facilities. We can clearly find in the current literature ecosphere a number of algorithms that are highly performant. But how do you quantify or how do you specify which one is fundamentally useful for our work? This is the objective of our research. To study regional-based algorithm, specifically Detector-RS, and single-shot detection algorithm, specifically YOLO-R. And the goal is to evaluate and compare between these two models and to finally be able to do an implementation that takes in consideration the context. For this evaluation, we will need to introduce a new set of contextual metrics. Thus, we are proposing safety, reliability, and efficiency as a way to define what makes a model fits to the criteria set by the ISO. How do we exactly test the performance? So we started with a fixed video for all our testing. This video is subdivided in 1,000 frames and it has 1.3 obstacle per frame. Just by plotting the number of detection per frame, we can clearly see a difference between Detector-RS and YOLO-R. While YOLO-R displays a higher mean average precision, we can see that there is fluctuation in the detection that might be representative of instability. When we discuss about navigation, we have to put the word real-time system. And for the purpose of a real-time system, you need a very high frame rate. This is because the reaction time of your algorithm is very essential for the safety of your system. When comparing the frame rate from YOLO-R to Detector-RS, we quickly see that YOLO-R displays 50% higher frame rate. This is very essential for our contextual situation. And this is why YOLO-R for the next phase will be implemented. So how about our expected outcomes? Basically, after generalizing and synthesizing a new contextual metric based both on the international standardization and also existing evaluation methods, we can prove the validity of YOLO-R by implementing it or by applying it to a real scenario. What is the real scenario in this case? We have collected testing dataset from a real-time hospital. More precisely, Hospital Sultan Amina in Johor Bahru. This testing set serves as a method to optimize the YOLO-R algorithm and produce the most suitable model that could effectively drive a wheelchair throughout the facilities. This is a way for our research paper to prove the safety, reliability, and efficiency standards required in a medical field. Thank you very much for listening, and it was a pleasure to share my research during this IUPC 2022.